In this unit, we talk a little bit about blood. We're going to talk about the qualities of blood, the different characteristics, and the different cells that are involved in blood. So, a little bit about blood in general. It is the only fluid tissue in the human body, and it is classified as a connective tissue. It's classified as a connective tissue because the cells don't touch. Um, The components of blood include some living cells, which are the white blood cells. What we think of as blood cells, the red blood cells, are actually not cells. They are what we consider formed elements. Uh, that is, they don't have the nucleus, they don't have anything left to do any kind of repair. They are largely sacks of chemicals. So the formed elements consist of red blood cells, platelets, a number of proteins that are involved in maintaining fluid and electrolyte balance, maintaining hemostasis in terms of clotting, and then, of course, the non-living matrix that is in all connective tissues, which in this case is plasma. Now, the physical characteristics of blood, I think we all probably have a pretty good idea of what blood is like, but still, color range, if it's oxygen rich, the blood is scarlet red. If it's oxygen poor, it's actually a dull red. It is not blue. The blue color that you see in veins is a product of the connective tissue that's actually surrounding those vessels. Um, Blood can be actually a very brilliant red if it is bound to carbon monoxide. Um, so, kind of a third color option there. The pH in blood is between 7.35 and 7.45, and we've mentioned that before as for the pH in the human body. Blood temperature is actually higher than body temperature, and as a result, we can dilate blood vessels and allow the blood to flow to the surface and get rid of excess body heat. Now, in a healthy male, blood volume is about 5 to 6 liters, or ballpark 6 quarts. Uh, can be a little more, can be a little less. In the end, blood makes up about 8% of our body weight. You may have heard before a pint's a pound the world around. And so if we're looking at 6 quarts, that's about 12 pints. That's about, 12 pounds. Again, kind of a ballpark there. Now, if you were to take a sample of blood and centrifuge it, that is, if you were to spin it at a very high speed, what would happen is that the heavier elements would sink to the bottom. This would include the erythrocytes, which are the heaviest portion, part because they contain lots of protein and iron, and that would sink to the bottom, and that would actually make about 35 to 45% of the blood. Measurement of this percentage is known as a hematocrit, and that is a quick and easy test that is done sometimes when to see if a person's lost a lot of blood. It is a way to see if they have certain anemias and things like that. The fluid portion will rise to the top, and that's the plasma, and that's about 55%. Now, there is a thin layer that exists between the erythrocytes, or red blood cells, and the plasma, and this is called the buffy coat, which contains the white blood cells, platelets, some clotting proteins, a few other things, but it is a little whitish layer that shows up in between. Now, the plasma itself, oh, sorry, different ratios of the cells can give you kind of a indication of if there's an infection, suggest what kind of infecting organism there is, and we will talk about some of the different cells that make up this buffy coat, which are the leukocytes, a little bit later on. Um, as I said, that test can be handy for just evaluating the proportion of red blood cells you have. But as we look at these cells, we're going to throw out some numbers. The only big one that I want you to realize is that there are 4 to 6 million red blood cells in every drop of blood. The numbers are staggering. But blood plasma itself is composed of about 90% water. It also has a lot of dissolved substances, nutrients, salts, respiratory gases, hormones, plasma proteins, waste products. The truth is that everything that makes it to every living cell that we have in our body has gotten there through blood or through the plasma. Something to be aware of. It is the transport medium of the body and serves some major functions beyond just the function of carrying oxygen to tissues and carbon dioxide away from the tissues. Now, plasma proteins. We have several. Uh, these are abundant in the plasma, more abundant than all of the other solutes. Plasma proteins are made by the liver, and they include uh, several, but there are a couple that are very important to us. Albumin, which is a protein that's also in egg, actually, and it regulates osmotic pressure. That is, it thickens the blood a little bit so it maintains this osmotic flow. Fluids don't exit the bloodstream as readily and they get drawn back into the bloodstream because of the presence of these albumins. We have clotting proteins, which help us stem blood loss when a blood vessel is injured. So, very important. It takes quite a long time for us to uh, rebuild lost blood cells, so we need to have a mechanism to keep us from losing too many. And then there are antibodies. And this ties in with materials later on in this testing unit when we get to the immune system. And so there's a lot of overlap between our discussion on blood and our discussion on immunity. Anyway, the antibodies are proteins that help protect the body from pathogens. These antibodies are made by certain cells called B cells that are in our bloodstream. Now, the formed elements consist of erythrocytes, which are the red blood cells, leukocytes, which are the white blood cells, and these are involved in our immune system, and then platelets, which are cell fragments, and they are involved in the clotting process. If you looked at an under a microscope, you might see all of these elements. As you can see, there's a number of red blood cells, which kind of have the shape of, they call it a biconcave disc. It looks sort of like a flattened out jelly donut. Um, you can see these white blood cells, and in this case, we have some neutrophils. There's one of the lymphocytes, another cell, and then these small dots, which are the platelets. Now, the numbers, well, we've got a variety of numbers. As I said before, erythrocytes make up 4 to 6 million cells. But from this table, which is in your textbook, you should understand the function of each of these cells. So erythrocytes, those are the red blood cells. That's the majority of it. And then we have leukocytes, which somewhere between 4,000 and 11,000 white blood cells per drop. I'm going to talk a little bit about each of these cells. The neutrophils, these are phagocytic cells. That is, that they go out and they eat up things that are foreign. These are in the highest number. These are the first cells to enter the scene when there is tissue damage or an infection. Neutrophils are called neutrophils because they don't pick up stain very readily. Um, they are part of a group called granulocytes, and you should know that the granulocytes consist of the neutrophils, eosinophils, and basophils. And the eosinophils are called eosinophils because they pick up a red dye very easily. This is called eosin. And eosinophils are involved in allergic responses. They are also involved in killing off parasites, specifically parasitic worms. Now, basophils also involved in the allergic response, but they are not involved in this kind of parasitic reaction. Now, I have a dog, and when she gets worms, um, she sits down and scoots on the floor. Now, that kind of makes sense when we think about allergic reactions, because what happens when you have an allergy, when you have a skin allergy, the area itches. So, in the presence of worms, the worms kind of moving through her digestive tract irritate the tissues, cause it to itch. There are also agranulocytes. Now, the granulocytes are called that because they have little granules that you can see microscopically. Agranulocytes do not, but they're still white blood cells. And this consists of the lymphocytes and the monocytes. Now, lymphocytes, these are part of the immune system, and they consist of B lymphocytes and T lymphocytes, and we will talk at length about these when we get into immunity. The monocytes, these are abundant cells. They are active phagocytes as well. So we have neutrophils that are phagocytic. We have monocytes that are phagocytic. Monocytes are in the bloodstream, but if they exit the bloodstream and get into the tissues, they transform into a larger cell called a macrophage. Macro being large, phage being to eat. And they clean up and tear down damaged cells. They are involved in chronic infections, whereas neutrophils are more involved in acute infections. We also have platelets, which are needed for normal blood clotting. They initiate what is known as the clotting cascade, and we will go through that process a little bit later on. So a little bit about the red blood cells, the erythrocytes, and their main function is to carry oxygen. They are these biconcave discs. They are essentially bags of hemoglobin, that is a protein with iron on it, and the iron rusts in the presence of oxygen and unrusts and releases the oxygen in tissues that need it. When we say a nucleate, they don't have a nucleus, and as a result, they don't have there's no mechanism for repair. And so their lifespan is not that long. It's about 120 days. They really don't contain any organelles. Anything that is left is just a remnant, but they eject their organelles early on in their lifespan. As I said before, we have between 4 and 6 red blood cells per cubic millimeter, which is the equivalent of a drop of blood. Now, erythrocytes are unable on their own to divide, grow, or synthesize proteins, so they are not cellular. They wear out in about 100 to 120 days, and when they are worn out, they become leaky. And cells in the spleen or the liver pick up this leakiness and capture these cells and destroy them. They are lost by stem cells within the red marrow of our bone, um, which, and you don't need to know hemocytoblasts, but know that there are stem cells that are producing additional red blood cells. Within red blood cells, we have hemoglobin. Again, it's an iron-containing protein. It binds very strongly to oxygen in the right environment, such as the environment in our lungs, but it is reversible. In fact, in tissues that are acidic, such as tissues that are using a lot of ATP, tissues that are being worked, the the iron releases the oxygen relatively easily. The other white blood cells, as was said before, leukocytes, these are crucial in the body's defense against diseases. They are complete cells with nucleus and organelles. So these are functional cells. They have the ability to move in and out of blood vessels through a process called diapedesis. If you watch the second of the Terminator movies, there was this silvery guy that could slide under doors, go through cracks, things like that, and that's essentially diapedesis. It's sort of an amoeboid movement. They respond to chemicals that are released by damaged tissues, and makes them chemotactic. So if there is tissue damage, these leukocytes get called to the area by the chemicals released. Again, there's about 4,000 to 11,000 white blood cells per cubic milliliter. You don't need to know that number. However, just if you fall below 4,000, then you are susceptible to diseases. Over 11,000, you may have a disease that's causing your immune system to ramp up a little bit. At this point, we are going to stop and pick up talking about the formed elements, specifically granulocytes, agranulocytes, and talk about their characteristics. So that will be part 2 of this presentation.